Mm. Logic analyzer.
Whenever we connect the logic analyzer, we have to go to the trigger and we have to change the source to the D0 D0. Then the channel, the source will be changing, and this is the MSO connection we have connected, and this is the port. Once we on, so wherever we connect, these ports will support D0 to D7 or D8 to D15, to anywhere we can connect. So now I have connected to D0 to D7. Okay, so this is the bus cable we have connected. Other side we have the 8 channels we can interface. So these are the probes where we can connect to the 8 signals. So just I am opening this. Just I am connecting some. I will for as a demo I am showing 2-3 cables. So this here we have the slot. So in the slot it has to sit, this probe it has to sit. So 0 starts from this side, 0 starts from left, it end 7 is at right side. So this is the cable. Here at this point you can see this is the probing. On your PCB board, if you have the pins, so directly you can probe like this. Okay, or else we have the other clips for assembly components. Actually for this, if you have the individual ground, so these are the individual grounds where you have to connect at this point. Okay, these are the 8 ground cables. If you have the only common ground on your cable, so this is the common ground clips where you have to connect at this common ground. So here we have to connect these two. Okay, if you have the assembly components on your board, so these are the clips you have to connect at this end. Okay, this end here, inside this we have this pin type. So this female will go into this male. Okay, so then you can use this as a clip. Okay, so this is how your MSO works, right? So these are the 8 channels I have switched on. So now I will try to connect any of the signal here. Okay, like this with the vertical scale, even we can give more spacing to see your clear this thing. Okay, like this you can, if you have any signals, you can connect it and you can see the waveforms on your display.
Instead of using those channels?
No, actually these are unlock channels. In unlock channels you can see either square wave or sine or rectangle. Okay, and when you go to this logic channels, like in the, if you see in a digital data, it will be like zeros and ones. Okay, it will, if it is a 0 it will be the flat line, if it is a 1 it will go up. Again if it is a 0 it will come down, or else it is a 0 1 1 flat, 1 2 signals will be there, again zeros. Yeah, so normally these logic channels will be the 8-bit channels, 8-bit only. So once you connect, so this is all these things. Even you can give the threshold. Already couple levels are there, so these things are this common. If you want to set individually, so you switch off these couple levels, and here you can give the your own this thing in the when you in the like TTL, CMOS, ECL, these things you can give, and you can give the threshold level up to -8 volts to plus volts.
Okay.
And this have small, medium or high, it is for the display purpose. Okay, this is how your MSO works. Actually here we don't have any MSO signal. Next time whenever I am coming, or at least I try to get some board of MSO and I2C signals where I can easily demonstrate to you. Okay, what else here? Still MSO is over. So here we have the other protocols. Here you can do the power analysis. Like even in this, even you can measure your harmonic analysis. You can measure your harmonic analysis.
Harmonic content up to how much order?
I'll show you. Up to 60 hertz, we can measure up to 50 hertz, 60 hertz. Like here we can connect, we can see the voltage harmonic and the current harmonic. If you see, this is a C1 is a voltage, C2 is current. Like this we can connect 4 voltage, 4 currents, and we can see the harmonics of that. And it is a 50 hertz, 60 hertz fundamental up to we can see this. Okay,
Harmonic order
harmonic order
up to
meter option is nothing but with the same oscilloscope probe. If you want to measure any DC voltage on your board, no need of additional multimeter. So with this passive probe we can measure the DC voltage, only DC voltage. So there where it will display here. So this is like a small, this is a small application where it is useful to measure the DC voltage. And here we have the counter also. This is nothing but like a frequency counter, but we call it as a trigger counter. After the trigger, how many waveforms has gone? Just I will show you. Here I am doing the counter option. You can see after the trigger, it is called a trigger counter. After the trigger, it is showing the frequency. If you see after dot, it is showing 3 digit of values. It is like a frequency counter.
Okay.
So this is here we are giving as a 1 kilohertz. So it is showing 999.9993 hertz. Okay. So this is a one more option. Apart from this,
Bode plot.
Yeah, Bode plots. So here we also can do the Bode plot analysis. So with this even we can do the Bode plots, and these are the protocols: SPI, I2C, UART, CAN-LIN. CAN-LIN is most used in the automobile. For automobile example, I can say you people might have seen the Audi car when you switch on the indicator, right indicator, left indicator, it will come point by point. Like if you say example at the Q7 of Audi, like they have used our oscilloscopes. Audi people, they have used our oscilloscopes. So point by point it will come. Like whenever you switch on the indicator, so it will come like this. So this can be defined in a CAN protocols. So mostly CAN protocols is used in a mill stand in automotive. Okay, these are mill standard. Mill standard is for the defense, the components which you design, develop. So you have to qualify the mill standards. So these are some protocols. So this is the RNA keys for the aircrafts and helicopters for this HAL people, like Air Force people. Okay, this is the audio, and this is I2S and TDM. In this we can do LJ, like left adjustment, right adjustment, time division multiplexing. So these can be done in these things. Okay.
So